Hello students. After completing the first and the second method to prepare haloalkanes, that is, we prepared haloalkanes from alkane by chlorination, bromination, iodination. We also prepared haloalkanes from alkenes, wherein we also made use of Markovnikov's and anti-Markovnikov's rule. Then we partially completed preparation of haloalkanes from alcohols, where alcohols were treated with phosphorus halides like phosphorus trichloride, phosphorus pentachloride, thionyl chloride, thionyl chloride being the best reagent. And we moved to phosphorus tribromides, phosphorus triiodides, which were freshly prepared in a C2. C2 is a reaction vessel where a substance is freshly prepared, is generated. Now today we are discussing further the preparation of haloalkane. Again, we are preparing them from alcohol only. From alcohol, we are making use of halogen acids. So we'll prepare haloalkanes from alcohols using halogen acids. So action of HX. We know the order of reactivity of HX. HI is greater than HBr. HI greater than HBr and HBr is greater than HCl. Now we use the first one, A, using concentrated HCl, that is gaseous HCl. Order of reactivity of alcohols. Order of reactivity of alcohols during C-O cleavage is 3 degree alcohol more reactive than 2 degree alcohol, more reactive than 1 degree alcohol. So in order to do the same kind of reaction in a tertiary, secondary and primary alcohol, the reaction conditions will alter. So for example, I take a primary alcohol, ethanol. Ethanol is also known as ethyl alcohol in common system. It is also known as grain alcohol since it is obtained by fermentation of grains. This much part of the alcohol, this COH is also called carbinol. Hence, this is a methyl carbinol, another name. So, this molecule is called ethyl alcohol, methyl carbinol, grain alcohol, ethanol, or simply called alcohol. When it is treated with HCl, concentrated, then the reaction takes place only in presence of anhydrous zinc chloride. So we are getting a molecule of ethyl chloride and a molecule of water. But for this reaction to happen fruitfully, we must heat. We must heat. When I take a secondary alcohol, Here I am writing the structure of a secondary alcohol. I am placing the dash OH on a 2-degree carbon and I treat it with HCl, concentrated, that is gaseous. Again I need to use anhydrous zinc chloride. Heating is not required. Secondary alcohols are more reactive than primary. Secondary alcohols are more reactive than primary. This goes. And I'll be getting a secondary alkyl halide, which is 2-chloropropane and a molecule of water. Since tertiary alcohol is most reactive, see, the tertiary alcohol reacts simply by shaking with HCl. Simply by shaking with HCl, which is concentrated at room temperature. No need to add anhydrous zinc chloride. This goes. So I immediately get tertiary butyl chloride, that is 2-chloro-2-methyl-propane and a molecule of water. So from here you can understand tertiary alcohol being most reactive reacts directly with concentrated HCl just at room temperature. Secondary alcohol being little less reactive needs anhydrous zinc chloride, and primary alcohol being least reactive not only needs anhydrous zinc chloride but also needs to be heated. One very important thing here, children, this reaction can be used to distinguish. This reaction can be used to distinguish between primary, secondary and tertiary alcohols. This reaction can be used to distinguish between primary, secondary and tertiary alcohol. And this mixture of concentrated HCl and anhydrous zinc chloride is called Lucas reagent. It is called Lucas reagent. It is called Lucas reagent. So Lucas reagent is a mixture of concentrated HCl and anhydrous zinc chloride. When I treat a 3-degree alcohol, with Lucas reagent, then I get immediate turbidity. I get an immediate turbidity. Turbidity means precipitate, unclear solution. Because when tertiary alcohol is treated with Lucas reagent, then immediately a tertiary alkyl chloride is obtained, which gives immediate turbidity in the test tube. But when a 2-degree alcohol is treated with Lucas reagent, then we get turbidity after 5 to 10 minutes, because secondary alcohols are less reactive than the primary and the secondary alcohols are less reactive than the tertiary alcohols. And primary being least reactive, see the problem with primary, the problem with primary is when a primary alcohol is treated with Lucas reagent, then no PPT, no turbidity. Without heating, we can't get turbidity in a primary alcohol. Hence, Lucas reagent can be used to distinguish between primary, secondary, and tertiary alcohols. With this, we move to preparation of alkyl bromides, wherein we will be making use of HBr and not HCl. And we will also see what is the difference in the reaction. So, here we go, using HBr. The most important thing over here is bromoalkanes are prepared by heating an alcohol. Bromoalkanes are prepared by heating an alcohol with constant boiling HBr, which is 48%. Or we can also prepare bromoalkanes by treating HBr by first generating it in a situ using concentrated H2SO4 on KBr or NABr. Let us see an example. I take propan-1-ol. I take propan-1-ol and I treat it with HBr. I take propan-1-ol, I treat it with HBr. Of course, in presence of concentrated H2SO4, heating, so I am putting the heat sign, and here this goes. And I get 1 bromo propane and a molecule of water. So a primary alcohol is treated with HBr in presence of concentrated sulfuric to give a primary alkyl bromide and a molecule of water. What else I can do? Or I can also freshly prepare HBr in a situ by treating KBr with H2SO4, which produces HBrN KHSO4. So HBr is freshly prepared by treating KBr with sulfuric acid, giving us freshly prepared HBr and KHSO4. The so generated HBr can react with a primary alcohol. Very specifically, I am saying primary alcohol because we can't prepare secondary and tertiary alkyl bromides here, and we get, I'm just completing the reaction, ethyl bromide plus a molecule of water. The reaction can be written in a single step in this manner. I'm just writing one step now. See how we write one step. Ethanol. This cancels. This cancels. So ethanol plus KBr plus H2SO4 gives ethyl bromide plus KHSO4 plus some alkyl of water. So same thing can be written in one step. Very important thing to note over here is we cannot prepare 2 degree and 3 degree alkyl bromides in this method. We cannot prepare 2 degree 3 degree alkyl bromide because a 2 degree and a 3 degree alkyl alcohol undergoes dehydration in presence of concentrated H2SO4 to form alkenes. After this, we can move to conversion of an alkyl alcohol to an alkyl iodide. We've done alkyl bromide, so we can convert it to alkyl iodide now. We'll just erase this and we proceed further. I hope it's clear till here. Obviously. Now the third category here, we're using HI. Now the alkyl iodides can be obtained from alkyl alcohol by refluxing an alkyl alcohol with constant boiling HI, 57%. Refluxing means vaporization, condensation reaction. Refluxing the alcohol with HI. And the HI is 57%. So here we go. We make the equation. Again, I am taking ethanol, a primary alcohol, because here also we cannot make use of secondary tertiary alcohol. It reacts with HI, 57%. Let us mention above the arrow, reflux. Let's go. So we get ethyl iodide and a molecule of water. Or children, here also we can freshly prepare HI in a situ by treating Ki with 95% phosphoric acid. Ki plus phosphoric acid, H3PO4 95% gives Hi plus KH2PO4. This Hi can attack a primary alcohol. See, look at the bird. Propan-1-ol plus Hi. Hi is freshly prepared in a situ. This goes. And I get N-propyl iodide or 1-iodo-propane and a molecule of water. Here also, children, we cannot prepare secondary and tertiary alkyl iodides because a secondary and a tertiary alcohol with H3PO4, which is a very strong acid, this acid will dehydrate the secondary and tertiary alcohols to form alkene. One more very interesting thing over here is, if you have attended the lecture, if you were very attentive, then you must have noticed that to convert alcohol to an alkyl bromide, I made use of concentrated sulfuric. But to convert alcohol to alkyl iodide, I did not use concentrated sulfuric, but I used phosphoric acid. Let us see why. A very important NCERT question, which you can see in the AIO, page 379. And the question is, why? Why is sulfuric acid not used during the reaction of alcohol with Ki. Let us see this question. Why is H2SO4 not used during the reaction of alcohol with Ki? Children, the reason is, when Ki is treated with H2SO4, we get Hi and KHSO4. But this sulfuric, being a very good oxidizing agent, produces nascent O also. See how? H2SO4 gives H2O plus SO2 plus nascent O. This nascent oxygen attacks Hi and converts it to water, take here, and iodine. And iodine cannot attack alcohols. As a result, I cannot prepare alkyl iodides by using Ki and sulfuric acid, but I have to use Ki and phosphoric acid, which produces Hi, and that Hi is stable, but here the Hi is unstable and it reacts back with oxygen to become iodine. So, HI does not react with alcohol, and unless and until it doesn't react with alcohol, how will I get alkyl iodide? So children, this lecture was a very conceptual lecture. Very interesting new things you could know in the lecture. Hope you enjoyed the lecture. Take care of yourself. Stay blessed. Love and blessings to all of you.